After 17 years, here's the database index explanation I wish someone gave me on day 1. Visual, practical, 5 sections, 4 minutes. I am Vera. 17 years in data and AI distilled. First, the B tree. Almost every index you'll ever create is a B tree under the hood. It's a sorted tree of pages. The root partitions the key space. Children narrow it. Please point at the actual row. To find any row, the database makes log n hops. On a billion rows, that's about 30 hops instead of a billion. That's the entire magic. When to add an index, 5 places. A column that shows up and we're on big tables. A column that joins to another table. Foreign keys, almost always. Order by columns the optimizer scans. Group by columns on hot queries. The simple rule, if the query planner can use the index pays off. When not to add one, write heavy tables. Every insert updates every index. Low cardinality columns like booleans. The planner ignores them. Small tables, a full scan beats an index lookup. Columns wrapped in functions like lower or date. The index can't be used, and just in case, a dead index costs writes forever. Audit indexes quarterly. Composite indexes, column order matters. An index on user ID and created at, in that order, is 2 indexes for the price of 1. It accelerates queries that filter on user ID alone, and queries that filter on both. But a query that only filters on created at skips the index entirely. Rule: put the most filtered column first. The covering index pattern. A regular index gets you to a row, then the database has to fetch the row from the table. 2 I/O operations. A covering index include the columns the query needs, so the lookup alone returns the answer. 1 I/O instead of 2. On hot queries, this is a free latency cut. Subscribe to Data and I with Verath. Tomorrow, the one SQL question that ends every data interview.